this this is a paper. So on let me back up. On Saturdays, no Saturdays, we have a weekly reading group on computational cognitive science and applications to AI. And this week we're going to try and read this paper from Probability Consilience, How Explanatory Values Implement Bayesian Reasoning. And this thing has, somebody just featured this on a podcast, so I want to actually maybe look at that. Is there anything that makes reading a paper easier? I've never heard of this Jim Rutt show. But let me get spun up here. All right.
Howdy, this is Jim Rutt, and this is the Jim Rutt Show. This is a Currents episode. Currents are shorter and less heavily produced than our full-length episodes and generally focus on a single topic. As always, references to online resources mentioned.
All right, so we got to go and listen. So this is a reading group on computational cognitive applications to AI that we run through the All Deep forum. If you're interested in joining, just message me on somewhere on social media, and I'll add you. Usually you have to pay, but we'll figure something out. So this looks at this from probability. Let's actually look at a review, the abstract. Recent work in cog size uncovered a diversity of explanatory values or dimensions along which we judge explanations as better or worse. We pose a Bayesian account of how these values fit together to guide explanation. The resulting taxonomy provides a set of predictors for which explanations people prefer and shows. Oops, I think I might have. So explanations people prefer and shows how core values from psychology, stats, and philosophy of science emerge from a common mathematical framework. So all right, that sounds a little bit too good to be true. But yeah, so we've been going through a big long reading list. I think I'll show it to you. Where's that list? Nope, that's not it. All right, here we go. We've been working through this long. Oh, where's the list? Oh, that's not it. Oh, that's supposed to be it. Here, so we've been going through this big long list of kind of tying explanation to causality and applications to artificial intelligence. So, and that's what we're doing this time. This is suggested by Payam. It's a member of the community, and so our idea here is to be able to, let's just read this and see how it sounds. But I want to listen to the podcast first, just in case it's more interesting.
In the episode will be available on the episode page at jimruttshow.com. It's somewhat annoying, but a fact of the podcasting ecosystem that getting good ratings increases our visibility on Today's guest is Simon DeDeo. Simon is assistant professor at Carnegie Mellon University in the Department of Social and Decision Sciences. There, he directs the Laboratory for Social Minds. He is also a member of the external faculty at the Santa Fe Institute. And, unless he wins a Nobel Prize, certainly a possibility, perhaps he'll be best known as the first guest on The Jim Rutt Show. Yep, Simon was EP1. I didn't know what the hell I was doing, but thanks to Simon, it turned out to be a classic nonetheless. Check it out. Ability to consilience. How explanatory values implement Bayesian reasoning. Quite a mouthful, but I'm sure it'll all be much clearer by the time we're done. Simon's co-author, to make sure he gets due credit, was Zachary Waltowicz. Is that pretty close?
Sure.
All right. So let's jump in. I mean, the sort of the subtitle or the subtitle something. Basically, you said what your goal here was explaining explanation. What do you mean by that at kind of the highest level?
So, Zach and I, both of us, and I should say Zach's a graduate student, right? So this is him building his career. It's very exciting to see. We have both been enchanted by, excited by, certainly interested in machine learning, right? The use of AI to get things done perhaps in a more efficient way, in a fairer way, one hopes. Machine learning computers, the way we reward them, the things we strive for, we want them to be really good at predicting the world. And I think we have missed something crucial about the human experience, which is actually, Jim, first of all, we're terrible at predicting the world, right? You and I, right? I mean, maybe you're better, right? But I'm terrible at it. We're terrible at predicting the world. And actually, most of the time, when we talk about the future, right? And in fact, most of the talk we do is not about prediction, but about explanation, trying to make sense of the things that have already happened. So you and I might say, you might say, why has social media gone bananas right now? What we're doing there, and the kind of conversation we're going to have, is a conversation that attempts to, in some way, make the events of the past comprehensible to us. We want to make sense of them. We want to say, for example, why they happened, or perhaps how they happened. Only as an ancillary to that do we care if anything we say is useful for predicting what happens next, right? So, Zach and I, one of the things we wanted to do was just focus on this really fundamentally human task. We come at it as cognitive scientists, but we're also hoping to, in some way, connect to the work that's being done in AI. Right? If AI is obsessed with prediction and humans are obsessed with explanation, maybe we can tell a story mathematically in the language of AI, but about human things.
Very, very interesting. And you guys talk about the fact that, explanatory values appear very early. Kids are always trying to explain things, and sometimes the explanations are pretty funny. But talk about that a little bit, how, from a human development perspective, the idea of explanation starts to come into our lives.
This is something that was really exciting for me, and I had no idea the extent to which something I thought of as a really advanced thing, right? It's like, let's explain the electromagnetic field. That's fun, right? But looking into the research done in child development, it's amazing how quickly children are interested in building explanations. And in fact, we can see some of the same biases, some of the same predilections in how children explain things that adults also have. One way to think about it, a couple of years ago, we got really interested, people got very interested in how our sense of beauty was quite universal and quite learned quite early, at least some aspects of it. So we see a preference for symmetry, right? We see, children look longer at things that adults consider beautiful as well. So there's a sense that children share aesthetic values with adults. These develop very early. In a similar way, it seems like, and this happens at age 3 or children have similar tastes for what makes a good explanation that adults have. Some of the basic features are already in place. And so, some aspects of explanation making, maybe we learn them in college, but a lot of really kind of, low-level operating system stuff is baked in very early.
sort of makes sense, but it's also kind of surprising, right? We haven't been doing linguistic explanations for all that long as a species, somewhere between 35,000 maybe and 100,000 years, and to have developed a kind of a consistent taste and explanation already is kind of cool. Going a little further into your paper, you talk about two descriptive lenses or explanatory lenses for explanation: the lens of description and the lens of power. Why don't we talk about those a little bit?
Right. So, and I really want to bring this down to a kind of just ordinary stuff, right? Jim, it's like, my computer won't turn on. Why? Right. My friend didn't call me back. Why? These are things we do all the time, right? And one of the first points you make in this paper is that you always have two things in play. Okay? You have, on the one hand, you have what the explanation does for the data you have to hand, right? So, my friend, didn't ring. Okay, one piece of data might be, did he, is he chronically forgetful? Another piece of data might be, is he, was it late at night? Another piece of data might be, is it Saturday? Did it happen on a Saturday as opposed to a Thursday? So there's all these facts that are sitting there. And one of the things an explanation does is, make sense of these facts. And we evaluate the explanation in terms of how well it does at predicting, or at least, making more or less likely the facts you have. So, why didn't my friend call? He didn't call because his phone was broken, right? That's an explanation. His phone died, right? But then you might say, but you know what? Like, Susan got a call from him, 10 minutes after he was meant to call me. So all of a sudden, this explanation doesn't look as good. And the reason it doesn't look as good is because it just doesn't fit the facts. So that's one thing that's always in play.
And that's the descriptive lens.
Exactly. That's, description is part of that. It's like, hey, that's a terrible explanation because, like, you've only explained half of it, or it even is contradicted by the other stuff I know. So that's one thing. But another thing is sitting on the other side, let's say, of this divide, and that's the theoretical side. So if you have the empirical aspects of an explanation, you also have these kind of theoretical values. And the theoretical values are about what the explanation itself looks like, how it fits pieces together. And not just facts, right, but other things that you might not observe, stories about the world, the ways in which, different aspects of things fit together. What potentially causes what could cause what, right? So, why didn't he call? Al, you know what? The guy is just fundamentally a bad guy. Now, one part of that explanation that you might value is, it fits all these other things I know about him. Another thing is you're like, you may like this kind of hidden common variable story where there are good people and bad people in the world. Right? So, this is, the first kind of step that Zach and I took was to tear apart these two pieces and look at them in isolation. So one of the things is that once you realize these two pieces split apart, another thing that you have is like, maybe these go to war, right? So maybe there are explanations that don't fit the facts very well, that, get out-competed by other explanations that fit the facts better, right? And yet that bad explanation from the point of view of the facts may be good for you, perhaps, as a kind of just fallible human being or a human being with values, right? That explanation might be good because of its theoretical merits. So you start to see maybe we can explain why somebody will hang on, let's say, to an explanation that from your point of view and from the point of view, let's say, the facts is just completely inadequate, right? And yet, potentially, right, this person might be holding that belief because of other epistemic values that are sitting in there. And these are these theoretical values. So power is one, unification is one, parsimony, simplicity. These are things that are sitting on the other side, right? That are sitting in a more abstract Platonic space, if you like.
Yeah, now, it's funny. I kind of thought of parsimony and simplicity as somehow different than unification and power. What do you see about those that unifies them?
Right. I mean, what you've done there, Jim, and this is something that Zach and I had all the time, which is really funny, is obviously this paper, right, is about explaining explanation. So hopefully, right, we can make sense of our own paper in our own framework, right?
One would hope.
One would hope, right? Yeah, I had a wonderful conversation with a group in the philosophy of science department, at the University of Pittsburgh, this was pointed out, right? The unification is a really fun value. It's a theory that is unifying, right? Says that lots of things in the world, including stuff you haven't seen yet, lots of things in the world are connected in some, let's say, occult fashion, right? And I use the word occult in a kind of funny way, right? Because of course, the most unifying theories of all time are the ones in the physical sciences, right? The Higgs boson, right? The story of quantum electrodynamics, right? Tells you, out the other side of that thing, you get an enormous number of phenomena, all of which are driven by some underlying field, right? Some magical number that is sitting everywhere. So that's wild, right? Physics is a paradigmatic place where valuing unification has taken us a long way, has done really well for us. But when I use the word occult, right, another way to use it is like crazy. It's all the nutcases, right? It's all of the people who hold on to beliefs, let's say in I was going to say astrology, but I think there's something to astrology. Beliefs in Gaia is guiding all of human life towards some great apotheosis. The chemicals in the water are affecting our precious bodily fluids and driving us all crazy, right? So this value of unification is it's a double-edged sword, right, for us in many ways, and it is to go back to this split that Zach and I identified. It is one of these things that sits over on this theoretical side, and thus to a certain extent, it's a little bit in the eye of the beholder. It's like, if you like unification, and I'm someone who's prone to it, Jim, I'll tell you a story if you like about this. But if you like unification, you're going to prefer certain kinds of explanations. You're going to have an intrinsic drive towards them, for better or for worse.
Yep, and we talked about that, I think, in our first episode. I called it Harry Selden syndrome, right, from the Foundation trilogy, where many of us impressionable 10-year-olds, when we read the Foundation trilogy for the first time, said, "Damn, psychohistory, that would be cool. Have one set of equations that could predict all of human history. Holy shit!" Right?
Right, exactly.
And knowing when unification type theories make sense and when they don't might be an important second order human skill, right? As far as we know, every electron has exactly the same mass, right? Which is pretty goddamn interesting, right? And we can, at least at the moment, take that to the bank. And yet, other unification theories, all the world governments are controlled by reptilian humanoids from Tau Ceti.
Right.
It explains everything, right? And yet
it does, right? I mean, this is, Jim, I love this point you make, right? That these are second order questions, and I think and I won't speak for Zach on this, but one thing I think is maybe a question for us, to say as a species going forward, is can we get better at these second order questions, right? Can we start having conversations not just about explanations, right, but also about the principles upon which we accept and reject them? This is something at the Santa Fe Institute when I first showed up. This is like the cocktail party of every explanatory preference of all time, right? It's like the San Francisco bar, right? Mos Eisley Cantina, where the physicist shows up, right? And for them, the more a theory is unifying the phenomena, the better the theory is. And I remember a wonderful talk given by David Pines, who's no longer with us. David was presenting some work he had done on spin glasses, right, which is this very beautiful, abstruse chunk of condensed matter physics. And he's going on, and half this room is like just peeing themselves. We love it. And this biologist raises his hand, and the biologist is David Krakauer, who you know, so maybe he's wrong to call him just a biologist. But David raises his hand and he says, Professor Pines, David Pines, is there anything your theory cannot explain? and David says, the speaker David Pines says, no, isn't this wonderful, right? And for him, right, this is a sign of a good explanation, right? But for many people in the room, certainly biologists, right, this is a sign you've gone off the deep end, because life is a complicated thing. It's messy, it's genealogical, it's evolved, it has histories. The tape gets run only once, and so that a theory that is too unifying is probably off the walls. It's probably missing something. And so, we got used to this very quickly at the Institute of saying, okay, let's have a second order debate for a moment. Like, let's put aside whether or not we can explain, the collapse of this Aztec civilization. Let's go over to the non-collapse. Right? Let's go over to, how do you as an anthropologist value these things? How do you as a, let's say, sociologist value these things? As a mathematical physicist value these things? As an information theorist, game theorist? And all of these people are bringing different kinds of second order values to the table. That's great. It's a lot of fun. What I wonder is if we might benefit from having that conversation on a much broader scale. If this is the conversation we might have, let's say, in the university. Students go to university, they major in a subject. I see this at CMU, great, right? But at the same time, we train students to see the world a certain way. So when I teach a class and I have computer scientists and social scientists, psychologists in the room as undergraduates, you can just see, right? They've been trained into a certain set of explanatory values, and the clashes are amazing to see, right? The ways in which they, struggle, often very successfully, to say, it's not that my explanation, it's not that this person is not valuing my explanation because it doesn't fit the facts. It's because they have a fundamentally different aesthetic for what explanation should look like.
Yeah, we know what that reminds me of. There's all this debate about what the freshman distributive courses should be. I got a proposal for you. Maybe you should propose it to the head honcho there at Carnegie Mellon. How about a first semester freshman course on how to use many lenses?
Right.
And have people come in from each discipline and attempt to distill in 1 hour what lens is it that is the principal lens in their work, and maybe have a reading to go with it for the next class. So maybe it's two classes per lens. One a discourse on the lens by the practitioner, and then some readings, and then the guy comes back and just has the students say, how did you see this reading through my lens? Wouldn't that be interesting?
Obviously, Jim, this being Carnegie Mellon, right? We are miles ahead of the game, and we're on this. We run seminars here, freshman seminars. One of the ones that I did not participate in, but I would love to have been in, was a historian, if I understand correctly, and an epidemiologist talking about the Black Death. The bubonic plague in the 17th century and 16th, 17th century in Europe. And, the way a historian talks about and attempts to explain that, the way an epidemiologist talks about and attempts to explain that, they're complementary. But at this second order, you also start to get a sense of what makes a good historical explanation, before you even get to the data, before you even get to the archive, right? What does a historian value and what does an epidemiologist value? That kind of stuff is, you could overdo it, right? You could make everybody they all have second order opinions, but no first order abilities, right? You obviously want students to get really good at, let's say, running a set of equations forward, or let's say, understanding system 1 and system 2 in psychology. You want them to have the first order explanatory powers, but you also, I think, maybe this happens freshman year, and then maybe you come back to it senior year, you wrap all the way back around on the torus to reflect upon the last 4 years, the explanatory values you got really good at, and the ones that you might have neglected or in fact even been trained out of.
Yeah, that's even more interesting. And then sort of the second, or is it the third order, which is the discernment to know what lens to use in which situation.
Well, I mean, right? Wouldn't we love that, right? We have 8 different selves, and we know the right self to pick at any point in time. You know, a big chunk of this as metacognition, right? Not just knowing things, not even just knowing what you know, but having some awareness or some ability to understand the ways in which you came to know something. That knowing and here and for Zach and I, right, in this paper, knowing is explaining. It's one part of knowing, right? But that's the page we're on. Being able to say, well, what is it about this explanation that gives me the sense of knowing the answer? And is that a valid? Is that a reliable? Is that a productive way to go about the knowing task in this case?
And we'll get a little bit to how to trade those off a little bit later. But let's dig down just a little bit. If you could make the distinction between unification and power. They're similar, but they're different. Why don't you distinguish between those two?
Right. Well, so a powerful explanation is one that can cover a lot of different facts, right? That it's saying it's making predictions about all sorts of different things. So obviously, electromagnetism is a powerful theory, but if we get a little bit lower level, right? You may have an explanation for your social circle that is really good. It says, you know what? If you say this to Jim, I'll tell you he's going to throw you out of the room. But if you say this to Sam, right? Sam is going to meditate on it for weeks and tell you you're a genius. If you say it to Mary, she's gonna nod like she believes you, but later she's gonna tell you what an idiot you are, right? You go on and on, right? So a powerful explanation is one that makes a lot of specific claims about the world. Now, okay, maybe they're accurate, maybe not. If you buy the explanation, maybe you think they're accurate or going to be accurate. It's the kind of explanation that, for example, it's the kind of explanation you want a consultant to have, right? You want him to say, look, I got an account for what's going on in HR. I'm going to tell you what's going on in your cash flow. Maybe this is something you want out of a car mechanic. Well, I'll tell you what's going on here. Your air conditioner's shot. Your alternator is about to go, and it looks like the undercarriage is starting to rust, right? So that he's explaining all of the bumps and knocks that's going on, and it's a powerful explanation in that case, for example, it's telling him what to do, how to work on your car. Now, powerful explanations are many ways, maybe we like them. And to be clear, right, these are theoretical values, meaning that you're looking, when I call an explanation powerful, I'm saying it's not about how well it fits the stuff I have. It's about the way it looks in isolation from the facts I have. Powerful explanations, though, may not be unified, right? They may not, for example, tie the world together. They may not say this thing that we see is dependent upon that thing. The car mechanic's explanation for all the things that are going on in your car may be powerful, but probably it's not going to be unified, right? Cars have many different things that go wrong. They probably go wrong roughly all at the same time, but the underlying cause of them is not correlated, right? What caused the alternator to go bad is, the plastic on the insulation started to, fragment, right? Fracture. What caused the undercarriage to rust is that, you parked it on the coast. So unification, right? Separate value. And in fact, these can sometimes compete. So, let's take, reptilian lizards from Tall Ceti. That explanation will be very unifying. But when you actually say, all right, what are the reptilians from Tau Ceti doing tomorrow? You say, well, these guys are pretty unpredictable. I can't tell you. Maybe they'll shut down the internet, but maybe they'll shut down the air travel. Who knows? So again, right? You think of these as different axes along which an explanation can be valued or not valued.
Interesting. Okay. And that's closely related to the concept of coexplanation. Why don't you lay that one out and how it fits with both of the ideas of unification and power? How about that?
Well, this is great, Jim, because, sometimes you always worry, right? It's like, you give your afternoon speech. It's like, is anyone actually listening? So it's great. Thanks for reading the paper, right? It's great. If we have unification on the theoretical side, it's got its partner, right? It's got its empirical partner, right? In physics, you have the supersymmetric partner. This is the empirical partner. So if unification is a property of a theory in isolation, right? Karl Marx, right? It's all the dialectic of history and the war of the proletariat. That's the theory. The co-explanation is, all right, let's look at the actual facts that we have right now, right? Let's look at the stuff we've got sitting there and the extent to which your explanation says that those particular facts are related to each other, right? So generally, right? I mean, there are exceptions. Generally, a theory that's high in unification, right? If it's correct, will also be high in co-explanation, right? It will say, that came up that way. This other thing came up that way. That's exactly how we predict. We predict when one is up, the other is down, and vice versa.
I missed that bit about
Co-explanation says that those particular co-explanation is, all right, let's look at the actual facts that we have right now, right? Let's look at the stuff we've got sitting there and the extent to which your explanation says that those particular facts are related to each other, right? So generally, right? I mean, there are exceptions. Generally, a theory that's got sitting there and the extent to which your explanation says that those particular facts are related to each other, right? So generally, right? I mean, there are exceptions. Generally, a theory that's high in unification, right? If it's correct, will also be high in co-explanation.
I didn't catch that.
It will say, that came, right? So isolation, right? Karl Marx, the theoretical side, it's got its partner, right? It's got its empirical partner, right? In physics, you have the supersymmetric partner. This is the empirical partner. So if unification is a property of a theory in isolation, right? Karl Marx, right? It's all the dialectic of history and the war of the proletariat. That's the theory. The co-explanation is, all right, let's look at the actual facts that we have right now, right? Let's look at the stuff we've got sitting there and the extent to which your explanation says that those particular facts are related to each other, right? So generally, right? I mean, there are exceptions. Generally, a theory that's high in unification, right? If it's correct, will also be high in co-explanation.
So
right?
what is co-explain? Facts are co-explain?
So generally, right? I mean, there are exceptions. Generally, a theory that's hot sitting there and the extent to which your explanation says that those particular facts are related to each other, right? So generally, right? I mean, there are exceptions. Generally, a theory that's high in unification, right? If it's correct, will also be high in co-explanation, right? It will say, that came up that way. This other thing came up that way. That's exactly how we predict. We predict when one is up, the other is down, and vice versa. So co-explanation you can think of as, like, let's say, the cash value of the theory's unification.
Okay, that makes some good sense, actually. Yeah.
I mean, one thing, it's funny. One of the things that's kind of in play for us, and this came out, I think I didn't really realize this, but it came out in when we presented this to the philosophers. One woman said, look, what you've got here, sort of an Aristotelian theory. And what she meant by that is, there's a lot of different virtues, right? There's a lot of ways in which an explanation can be good. And, the key here is moderation, right? You don't want to be a coward, right? But neither do you want to be foolhardy. And courage, the virtue of courage, is somewhere in between, right? You don't want to be somebody for whom the world is just a bunch of disconnected, fuzz, right? But you also don't want to be the person who believes that aliens from Tau Ceti are controlling everything, right? You don't want to be somebody who forgets about unification. who says it's not a value, right? Neither do you want to be a person addicted to unification. You want to be somewhere in the middle. You should value it. And the real challenge here, and again, look, I'm not an Aristotelian, right? But this is, I was told we came up with an Aristotelian theory. The virtue here is to value the values correctly, not to overweight, not to go to an extreme, not, for example, to be too enchanted by something like coexplanation, not to be too obsessed by it, not to be too wowed by it, to value it, but not to go overboard, to not make it the only value, to not make, let's say, an idol out of it.
Except suppose it really was reptiles from Tossetti.
You know, we do have a line in the paper. Sometimes conspiracies are true, and you know, I think that's the case, right? If you will never believe, right? If you have some, you know, sort of psychic block, or you have some prejudice, you know, you've listened too much to a teacher. If you will never believe that occasionally a small number of people get together in a room and decide something that, you know, ends up affecting, you know, billions of people, then you're missing out. Like, you're missing out on life. You're also missing out on the ability to make sense of the world. Because yes, you know what? Sometimes a small number of people working in secret do actually make things happen.
Yeah, it's relatively rare, you know, being someone who actually has worked in the White House, Wall Street, and big corporate America. I can tell you, those people ain't that smart, first. And the old mafia rule, you know, two people can keep a secret as long as one of them's dead, is also a truism. So, you know, while there are very occasional examples of successful conspiracies, you know, kind of my meta heuristic is those two things. Them people ain't that smart, and they all fucking blab. So, you know, the expected value of a conspiracy is low, hence you wouldn't expect to have very many of them.
Right.
But that's not to say that the number that exists is zero, which is interesting. So now let's turn to another area, and I think this is one I probably fall into using too much. I'm a sucker for the parsimonious, concise, simple explanation. Could you, you know, for our audience, tell what you mean by that, and what both the good and the bad of looking for arguments or shaving with Occam's razor provides when we're thinking about explanation?
So parsimony, and it's funny, right? So when we wrote this paper, I can't remember if we actually kept this sentence, but the more Zach and I talked about this killer word, simplicity, right, the more it started to look like a million different things, right? So our line, and the line, I think it's in the paper, is simplicity is complex, right? What simplicity is, we know that this is a value, right? And, you know, just roughly speaking, you know, it's like, it's simple, I love it, right? You know, if you or I were to say, you know, we're debating something, and I said, you know what, Jim, simply said X, right? When I use that phrase simply said, what I'm really doing is saying X is a good explanation because it's simple, right? I would never say, you know, if I were to say, said in a super complicated way, X, or, you know, to be complicated about it, X, you would be like, you would think I was criticizing the explanation. But if I said, let's get simple, simply said X, you know that I'm trying to promote it. So then the question is, what the hell do we mean, right? What is simplicity, right? One answer, and, you know, we have to give some definition. So, you know, our definition is, how easy is the explanation to state, right? But now the word easy is doing all the work, right? Parsimony is an example of simplicity. Parsimony is literally things like count the words. You have more advanced versions like count the, you know, number of bytes in the computer program that produces the explanation, right? You know, all sorts of ways into this problem. But simplicity is, to us, it's this kind of value that we get closer and closer to. We can, you know, touch it on different edges, but we can never really get right to the center. You know, there's all these different ways that people will look at an explanation and say it's simple. For us, we're still kind of wrestling with exactly what simplicity means.
And of course, historically, I think one of the great examples of where the scientific community came to use Occam's razor or simplicity to make a big leap was the Copernican revolution. At the time, Copernicus' theory of the sun and the Earth rotating around the sun didn't actually fit the data any better than the Neo-Ptolemaic with its epicycles within epicycles within epicycles, but it was a shitload simpler, right? And so I think people were attracted to the simplicity of the argument as opposed to that time the very baroque extensions upon extensions upon extensions of the old Ptolemaic theory to make it continue to predict as well. And then, of course, we got better observations, the development of telescopes soon thereafter, and next thing you know, the problem was resolved. But I think that was a very interesting example where simplicity actually was a big thumb on the scale of people's evolution of thinking about that particular question.
I think that's a great example, and in some sense, Jim, the Copernican revolution is our origin story for simplicity, right? It's this great moment in intellectual history. Now, of course, we overblow this a little bit. Like you talk to any historian of science, they'll cancel you in a minute, right, for the way we're making cartoon here. But let's use the cartoon. That is, it's such a clear case where simplicity is obvious to us and it's the right call, right? So that's a great one. In fact, that was one of the first ones that came up. We debated, all right, how can we quantify the simplicity of the Copernican revolution? Obviously, look, many people have tried to do that, and we can talk about those efforts. That's a really, let's call it a simple case, right? That's a case where it's pretty easy for us all to say, yeah, I get that, right? It's a little bit like why is Botticelli a painting beautiful? Well, you know what? We can all agree it's beautiful. Come on. We know that that's something in play. But when we come to, the 21st century, things are starting to look a little trickier, right? It turns out, let's say, that there are many different ways to quantify simplicity, and that they're sometimes in conflict. One of the ways that Zach and I give us an example. One of the ways people have tried to quantify uncertainty is something called the Aikaike Information Criterion, AIC, right? So AIC is like a little, it's a little piece of machinery. You dump your theory into the machinery, you grind it out the other side, it gives you a rate.
See, this is actually getting into some territory that I really like. So Aikaike Information Criterion is a statistical, is a statistic for evaluating the complexity of a model. And I've written before how it tends to focus on characterizing the structure of the model as opposed to other ways of thinking about complexity and simplicity, which is to talk about it in terms of the structure of the domain. I wonder if you talk about it. So in this case, it would be how you would, we talk about, when I say I explain something to you, there's some kind of semantic meaning behind what an explanation is. And so if I break down an explanation into its component parts, you'd probably understand them in terms of natural language. And so what's interesting here is if I can say characterize how complex an explanation is in terms of natural language, that's better than if I have to refer to some kind of statistic that talks about how many parameters are inside of a model. Hope he talks about that.
It's a number that starts at 0 and goes up, and the higher it goes, the less simple the damn theory is. People love this, right? And so, in fact, it's sitting inside most of the contemporary statistical programs, right? So if you're an economist or a psychologist or an epidemiologist, let's say, and you boot up Python or R, one of these programs, and you say, hey, look, do a linear regression on some stuff I care about, it will say, okay, look, here's how well it fits, meaning, here is the empirical value of your regression. And it will also say, here's the AIC, right? Here is our measure of how simple your linear regression is. And the simpler linear regression, it's a theoretical value. It tells you nothing about how well it works. It's just saying, it's pretty simple or not so simple. So, That is it's a way to cash out simplicity in a number and to sort of reliably compare, and reliably meaning not correct, but just gives you the same answer every time, reliably compare relative simplicities. The only question is, that I have, and many people do have, is that the right measure, right? If all of science just switched over to using AIC, would we have solved the simplicity problem, right? And
No.
my sense is no. God forbid we should ever offload our judgments of simplicity to an algorithm. But it's certainly, as we've gone from this intuitive sense that the Copernican revolution was good for us, we get all the way to the other side and we say, you know what? Maybe the problem is harder than we thought.
Yeah, and not all problems are reducible, right? We don't understand what is driving the complexity. There's the famous H.L. Mencken quote, which goes the other way, which is every complex problem has a solution, which is simple, direct, plausible, and wrong. Now he's going a little too far the other way, which is to avoid simplicity, as being itself wrong. Mm-hmm. This kind of get to our conclusion here. It seems like what you guys are saying is there's lots of different ways to think about our explanation, but perhaps there needs to be some higher order way of thinking about how we think about explanation. Some, with sort of the end of your title, let me pull it back up here. Bayesian. How do you apply Bayesian reasoning to thinking about these various explanations, and which methods to explain explanations are valid, and even how to make sense of all this? What can you say as kind of closing comments for our audience? Now that we know that we have lots of different ways of thinking about explanations, how do we think
He
about
provides
when
a straight up
and how
breakdown
to
there.
use them, and how to evaluate whether our using them is sensible, all that kind of stuff?
Well, there's sort of two things that I think this paper, is trying to get people to do. One thing is to give us a better sense of how humans work, right? How the human brain works, how the human mind works. Let's say mind, not brain. We want to know, what are we doing when we explain? What are we doing when we accept or reject an explanation? And, somebody fascinated by the species, right? I want to know that, right? And so this work here that we're doing is, you might say it's a little bit like figuring out what a human's vital signs are, right? What are the different vital signs of an explanation? What are the ranges in which we think there's health and illness? So that's one piece, right? We want to understand the mind. But there's another piece here, which you might call the engineering side, right? Which is, can this give us a path forward to thinking more clearly and in a better, let's say, second order fashion about how we should be making explanations. So you and I touched upon this a little bit, Jim, in the discussion of education. But if the first part of this work is figuring out the vital signs, the second part of the work is, well, how do we make ourselves healthier? What is health? What are good explanations? If heart rate, if variability of heart rate is a sign of health, right? How do we get people's heart rates to be more variable? Is it exercise? Is it diet? In the same way, for the question of explanations, we want to ask, okay, not in a top-down way, not in a authoritarian way, that's not our style, but how can having these axes help us improve, right? Help us get better.
Interesting. Yeah, I think that's good. Any final thoughts in the explanation of explanation?
There's a lot of stuff we're looking forward to doing, and you and I've touched on this a little bit, Jim. In passing, which is the defects, right? Which is the aliens from Tau Ceti problem, where from our point of view, it's the things that are good for us are also bad for us, right? If you don't have enough carbohydrates, you starve to death. But if you have too many, maybe you have a metabolic syndrome. So, one of the big questions we have now looking forward is understanding the pathologies better. Some philosophers, Kazim Qassam, great philosopher, has gave us the phrase vice epistemology. And for us, I think the real interesting social level question is the vices of explanation, not necessarily the virtues right now.
Let's wrap her up right there. Thank you, Simon, for a wonderful and interesting and hopefully useful episode.
Oh, well, that looks like was actually a good listen. With 10 minutes left, I'm going to go ahead and read through the instructions. So, intuitively, philosophically, and as seen in laboratory experiments, explanations are judged as better or worse on the basis of many different criteria. These explanatory values appear in early childhood, and their influence extends to some of the most sophisticated social knowledge formation processes we know. So we'll be curious to see what these explanatory values are. But I guess that means like, oh, here, down here. Maybe these things here. Okay. We lack, however, an understanding of the origin of these values or an account of how they fit together to guide belief formation. The multiplicity of values also appears to conflict with Bayesian models of cognition, which speak solely in terms of degrees of belief and suggest we judge explanations as better or worse based on a single quantity, their posterior likelihood. Interesting. So he's saying that we have a kind of almost a rubric for evaluating an explanation, and kind of a posterior likelihood is insufficient to capture all those elements. So in this opinion, we show how to resolve these conflicts by arguing that previously identified explanatory values capture different components of a full Bayesian calculation, and when considered together and weighed appropriately, implement Bayesian cognition. This framework shows how key explanatory values identified by laboratory experiments and philosophers of science, coexplanation, descriptiveness, precision, unification, power, and simplicity emerge naturally from the mathematical structure of probabilistic inference, thereby reconciling them with Bayesian models of cognition. Secondly, it shows how these values combine to produce preferences of one explanation over another. Third, it emphasizes new conceptual distinctions, such as one between explanatory values that could be assessed before the arrival of data, theoretical values, and those that can be assessed only after the arrival of data. Finally, it enables us to reinterpret work on the characteristic derivations from normative patterns of explanation that drive phenomena such as conspiracy theories, delusions, and extremist ideologies. So this is mapping somewhat to a prior in a Bayesian setting, and empirical values to the likelihood. And it also reminds me of how we do things in Bayesianism, which is we have a workflow where we check our assumptions prior to seeing data and then evaluate the data as a second step. Finally, it enables us to reinterpret work on the characteristic derivations from normative patterns of explanation that derive phenomena such as conspiracy theories, delusions, and extremist ideologies. It also removes a tension in the influential philosophical account of inference to the best. Let me stop. Like, this is actually, in all these conversations about explanations, our group has tend to kind of veered off into like, well, why do people believe in crazy stuff? And we try to figure out like, okay, what is the element of an explanation that makes one come up with extreme explanations? And this paper might be the first I've seen that address that question directly, so that's exciting. It also resolves a tension in the influential philosophical account of inference to the best explanation, which says belief formation is or should be guided by explanatory considerations. While some hold that IBE, what is that? Inference to the best explanation. IBE is incompatible with Bayesian updating because exploratory considerations cannot be captured within a probabilistic framework. Others argue that the two are either compatible or potentially even identical. We adopt the latter perspective and show how our framework provides a compelling, albeit preliminary, account of how such emergent compatibilism. I don't think I've ever seen that word before. Or that conjugation of compatible, can be achieved. All right, so we're going to say, recent experiments show that we value explanations for many reasons, such as predictive power and simplicity. Bayesian rational analysis provides a functional account of these values, along with concrete definitions that allow us to measure and compare them across a variety of contexts, including visual perception, politics, and science. These values include descriptiveness, coexplanation, unification, power, and simplicity, and fall into two groups. The first two are associated with the evaluation of explanations in the light of experience, while the latter concern the intrinsic features of an explanation. Failures to explain well can be understood as imbalances in these values. A conspiracy theorist, for example, may overrate co-explanation relative to simplicity. Wait, hold on. These fall into two groups. I thought it was description and power. Okay, evaluation explanations in light of experience, while the latter concern intrinsic features of an explanation. Okay. Failures to explain well can be understood as imbalances in these values. A conspiracy theorist, for example, may overrate co-explanation relative to simplicity, and many similar failures to explain that we see in social life may be analyzable at this level. Here we got this interesting graphic where we take an explanation and evaluate it on the basis of its log likelihood in the presence of evidence. So here's the posterior of explanation given evidence, and we break down into descriptiveness. So this is likelihood, and we're looking at the log likelihood here. And then what is this? All this stuff here must be prior stuff. So what is this thing? The log of I'm not sure this is how likelihood breaks down. We're looking at the product. I mean, this could just be plus the numerator here, which I think is just, wouldn't it just be equal to this? And the product of all of these, which is, how is that not the same as this? All right, this is going to require some explanation. And I think this is just, these two, this term and this term should cancel out. It's like, theoretical value. So this is just a big old prior, I guess. Contextual values, theoretical value. So descriptiveness, which measures the total extent. So this P function here is different in these two settings. But total extent to which the explanation predicts each fact in isolation from the others. Oh, I see, because this is saying, this is almost like a, it's almost like a, this is the marginal probabilities, and then these are some kind of, yeah, the notation here is odd, but I guess, okay, we're just saying that how well each fact is independently explained, and how much an explanation links the facts. All right. Evidence independent values and context dependent. All right, so here we have a bit of context, and then here we're talking about, like, what do I care about with respect to my explanation? I care about, is it falsifiable? If I see, like, to use his example, like if I if I hear an explanation that can explain everything, then I tend to discount it because it isn't falsifiable, even though something can be not falsifiable and be wrong. Anyway, I look forward to reading this. I might come back online in a little bit and give it a read. Got a half hour, but I'm going to stop. But I think I'll stop here for now. See you next time. Next time, so if you want to actually join our reading groups, just reach out to me, and I will be on. This reading group is on Thursdays at 6 p.m. U.S. Eastern Time. Incorrect. 12:30 p.m. U.S.